we've always had numbers, right? And with them, we've always had puzzles. You know, equations that kind of taunt us, daring us to find a solution. But what if an equation wasn't just hard? What if it was, like, fundamentally unsolvable?
I mean, that's a question that kind of shakes you, right? We all just assume that with enough brain power or enough time or some crazy supercomputer, any problem will eventually crack. But are some problems truly impossible to solve? Well, for 200 years, mathematics itself, one of our most basic fields of knowledge, smacked right into a brick wall. And we're not talking about a problem that was just unsolved. No, this was a problem that was proven to be unsolvable, at least by the rules everyone was playing by. And that's where this incredible idea from Professor Mourad Sultan Ezouidi comes into play. Today, we're going to dig into his wild claim that one of the most famous impossible limits in math has finally been shattered. So, yeah, let's get into it.
All right, first things first, we got to understand the sheer size of the mountain that needed to be climbed here. So what exactly was this unsolvable problem?
Okay, so this is it, the Abel-Ruffini theorem. It's a huge deal in algebra. Think of it like this. You can cook up one single recipe, a formula that solves any equation up to the 4th degree. But the second you hit the 5th degree or anything higher, this theorem says, nope, there's no single recipe for that. No general formula exists if you're using the standard tools of algebra. It's not just that it's super hard, it was proven to be literally impossible. And this timeline, wow, it really puts the scale of this thing into perspective. I mean, mathematicians cracked 3rd and 4th degree equations way back in the 1500s. But then, boom, 1824, Niels Henrik Abel drops this bombshell, and for the next 200 years, progress on finding exact answers just stopped, dead in its tracks. The book was slammed shut. Until, maybe, now. Just think about that. For over 2 centuries, literally every mathematician, every scientist, every engineer has been working under this one huge assumption. Some problems just can't be solved, period. That belief has shaped our entire world. So, who on earth would dare to challenge 2 centuries of accepted mathematical truth? Enter Professor Mourad Sultan Ezouidi. Now, he's not just suggesting, a little tweak to the old rules, no way. He claims he's done the impossible. He found an exact, symbolic solution for a 20th degree polynomial. That's not just a challenge to the Abel-Ruffini theorem. It's like walking right up to it and knocking it over. In this quote, I think it really gets to the heart of his argument. See, he's not saying Abel was wrong, not really. He's saying Abel's theorem was a landmark for the tools they had back then. It was a milestone that his new methods have now, well, blown right past. So, the big question, how is this even possible? Well, it all comes down to a really fundamental difference in approach. It's a classic case of old tools versus new ones. This right here gets to the core of why the old ways just didn't work. The old tools, these things called radicals, like square roots, cube roots, that stuff, they just weren't powerful enough. And the complexity, it just explodes. We're talking millions of terms. It's insane. So for 200 years, the best anyone could do was just get close, use approximations. And because everyone believed Abel's theorem was the final word, they basically stopped looking for a perfect answer. They just accepted that it was impossible. And this table just lays it all out, side by side. It's a total paradigm shift. On one side, you've got the classic methods, the word impossible since 1824, relying on approximations. It's all about accepting limits. But then you look at Ezouidi's theorem. Exact solutions, 100% verifiable. A total rejection of fatalism. It's not just a small change, it's a complete flip. So really, what we're looking at here is a clash of philosophies. Classical algebra looked at the problem and saw an unbreakable wall. But Ezouidi's work, it sees a door that was just waiting for someone to find the right key. It's a total move away from this idea of mathematical fatalism and into a whole new world of possibilities. Okay, so let's get to the main event. How in the world do you actually solve the impossible? Behold, the challenge, a 20th degree polynomial. This is the mathematical beast that Professor Ezouidi claims to have tamed. If you were to write this whole thing out, it would be an absolute monster. And with the old tools, forget it. Finding an exact answer is just not on the table. So instead of just trying to brute force the problem, this new method is way smarter. It completely reframes it. It uses a whole new algebraic framework, a new way of even looking at the problem.
Then it applies this really clever universal formula that just keeps building on itself step by step to systematically unlock the equation's hidden secrets and pull out the exact roots.
And here is the payoff, the impossible result. After running through this new process, you get the exact roots of that massive polynomial. And just look at them. They're so clean, perfect, symbolic answers. You've got things like 2i or this other huge number times I. There are no more messy, endless decimals. This is what it looks like when you turn absolute, overwhelming chaos into beautiful, elegant clarity.
Okay, so if, and it's a big if this claim gets verified by the rest of the math world, the implications are just staggering. We're not talking about just solving one hard math problem anymore. This is about potentially rewriting the fundamental rules of algebra. Because the ultimate claim here is that there is no limit. That unbreakable wall that Abel built 200 years ago, maybe it was never really there. The idea is that any polynomial, I don't care if it's degree 20 or 200 or 2 million, has an exact, perfect solution just sitting there waiting for us to find it.
And this quote just nails it. This could be a total revolution. The whole point of algebra would shift. It would no longer be about finding good enough answers. It would be about getting back to the original quest, finding absolute, perfect, precise truth.
So why does any of this matter to you and me? Well, for one, it challenges a truth we've held on to for 200 years. But more practically, it could give us perfect, exact tools for everything from physics and cryptography to engineering and medicine. Imagine a whole new level of precision in the tech that shapes every single part of our lives.
And all this just leaves us with one last, really fascinating question to chew on. For 200 years, it was an accepted fact that these equations were impossible to solve. If that fact can be overturned, it really makes you wonder, doesn't it? What other impossible things out there are just waiting for someone to come along and find a brand new way of looking at the problem?